Another excitingly boring video. In this video is part 2 of the Interactive Brokers API. Seems like people might be disappointed by the first one, considering it's only setting up the environment. If you'd like to see these videos done in a different order, leave a comment below and let me know. If you would like to see them done in a quicker time frame, consider subscribing to one of the financial paths. Anyway, so the Interactive Brokers API is definitely some kludgy code. So I'm looking at turning this sample code into a REST API web server, but for now I'm just going to talk through the code and show you how to use it. Before we get too carried away, make sure you log into Interactive Brokers with the paper trading account or in the demo mode. I ran the sample code and it made a bunch of trades right off the bat, so you definitely don't want to have this connected to your actual money account when you're dorking around with this. So first off, I needed to download and install Visual Studio 2015 with C++, then download their sample code, install that, navigate to the Python project and open up the project. Visual Studio needed to install Python support. In the Interactive Brokers application, you'll need to go to Settings and enable the API mode. Quick look at the two main files, program.python and client.python. These are the two main files that most of everything happens in. The client file connects to the Interactive Brokers application, processes all the messages from the Brokers app, and sends message requests to the Brokers app. The program file creates an instance of the client and connects the callbacks to its custom functions. First, it creates the test app class. This connects to the Interactive Brokers application. Then run is called to start the message loop processing. The test application class inherits the test wrapper class, and the test wrapper class has all the callback functions. Then the test client class is inherited. The test wrapper class inherits the eWrapper class. The eWrapper class is in the Interactive Brokers API, and we don't want to change that class. Then we have the test client class that inherits the eClient. Again, the eClient is in the Interactive Brokers API, and we don't want to change that class. But the run function that was called in the main is the run function in the eClient class. This run function processes the messages from the Interactive Brokers application as they come in. The connect function that is called from the main is the one within the eClient class. The test app class is overriding functions from one of the parent classes with the designation is wrapper. The decoder class is of interest because it has all the messages that it can process. It also shows you which functions are associated with that message. If we take a look at process tick price, you can see the properties that it gets from the message, and you can see which function it calls that will need to be overridden. In this case, it's called tick size. So we can go back to the test app class, look for tick size, and we have the function and what it will do. It just calls the parent tick size, which in this case the function is in the wrapper class, and prints out the properties of the message. So to get a tick size message, you have to call request market data. This will cause the interactive brokers to generate the tick size message, which will then call the overridden tick size function. But for implementation, I'm going to walk through the tick history function, and I'm going to walk through it backwards, because from a coding perspective, you find the function you want to call, tick history, then find the function that calls it, then in this case, uncomment that function so it can be called when I execute the code. And this is the output of the tick history. You can see the high, low, volume, etc. values. But I want to show the execution flow of this code before calling it this done. Basically, client.python has the message loop that receives the message, processes the message, then calls the function that you override, which does the work. Based on the work done, it will call a function to create a message. That gets sent back to the Interactive Brokers API or application. In this scenario, you would listen for each tick to come in. If the direction of the tick changes based on the change up or down, you buy or sell the stock. So the buy order or the sell order would create a new message, and that would get sent back to the Interactive Brokers application. But the application that I've built will not work with this execution flow. So I will be creating a REST API on top of this message loop. If that's something of interest, leave a comment and let me know. Or if you'd like to see this message loop that I outlined in the diagram implemented, let me know that as well. If you're not subscribed, I'm producing videos about coding on the regular basis. If you would like this content and want to see more, consider financially supporting this work. And again, thanks for watching. Till next video.